But kia ora koutou, welcome again to the virtual Atrium talks. And we're really lucky to have 4 speakers today from CMIC. So we've got Ian, Nadia, Moshan, have I said it right? Motion, that's right. Sorry, and Daniel speaking today. So I'll hand it over to them to do a fuller intro of themselves. And thank you very much for coming along and giving us this talk. So kia ora.
Thank you so much, Becky and Regan, for hosting us. Give me 1 second to just start up my screen. Ooh. Okay. Everyone can see this? Cool.
Yep.
All right. Thank you, everyone, for joining this talk. So we are quite sure that many people don't know about CMIC. So what we're going to do today is give a sampler of a bunch of different talks. A lot of them are in VR and AR, and hopefully give you a sense of who we are and what work we do. So just quickly about me, my name is Ian. I work at CMIC as a designer and innovation coordinator, where I primarily do a lot of work on project incubation. I'm also a School of Design alumni, so I'm really happy to be back here talking to everyone. So CMIC stands for the Computational Media Innovation Centre, and we're still super young, only 2 years old. And we're kind of based on the Faculty of Engineering. And we call ourselves an entrepreneurial research center. And what we mean by that, what does it mean when I say like entrepreneurial research, right? And one way we can think about it is that there's this horizon of emerging interactive media technologies coming towards us, whether that's real-time graphics and games with increasing realism, or cheaper and cheaper VR and AR headsets. And we need to ask ourselves, what kind of future does this enable? What kind of applications does it enable? And what is New Zealand's place in it? And certainly at CMIC, when we look to companies like Weta Digital, they've really proven that we can be pioneers in these areas. But in order to do so, there are lots of hard research problems we need to solve and address. And so CMIC's mission is to support that through user-oriented and industry-driven academic research. And naturally, this means that we work a lot in areas of game development, film production, of course, immersive technologies such as augmented and virtual reality. And what CMIC tries to do is that we want to be a bridge of sorts. And we're very lucky through our network to be partnered up with some of what I would argue the biggest players in these areas, such as Square Enix, OLM Digital, which you may recognize as the production company for the Pokemon series, companies like Bandai Namco, and be able to sit down with them and understand what is the future that they're trying to make, right? For example, what is the future of games? What is the future of VR and AR experiences? And what are the challenges that they need to overcome to achieve that? And funnel that back to Wellington, funnel that back to Victoria University, and be able to collaborate with everyone, all the different schools and departments and everyone here. And also, all sorts of companies in New Zealand, from startups to companies like Weta, to be able to say, hey, yeah, we can solve these problems and we can turn Wellington into this cool little innovation hub that is able to usher in this next wave of interactive media. And so specifically in CMIC, we have a number of groups that are working on different things to address some of these challenges. We have a Computational Media Solutions group, which is more computer graphics problems, doing a lot of machine learning, image processing type work. We have a group called User Experience and X Realities, who is about designing and evaluating, experimenting with new types of user experiences, new types of interactions, and certainly also a lot of work in VR and AR. And we have a group that I think is a little bit unique, which is called the Advanced Media Prototyping Group, whose job is to take a lot of that research and find new applications, new business cases, new ways to apply them, building new prototypes, applications and demos to be able to demonstrate the value of the technology and research we're doing. So what kind of projects are we working on right now? I'll give you a sense of it. So this is one of them. Can we train a computer to understand the environment by using a single image? So for example, what direction is the light coming from in the scene? What is the material that table is made of? So that the phones that we have in the future, or the AR headsets we have in the future, can better understand the world around us. What are the affordances that we have for immersive media content, such as 360 videos? Is it a new way for us to interact with videos? Is it a new way for us to create design visualizations? Or maybe a better way for us to engage with viewers and create new types of participation? As we move towards digital production, how might we preserve more traditional 2D styles that we might find in manga, comics, anime? And what makes a 3D model unique? What makes it recognizable or characteristic? And how can we use that information to inform and help artists build better assets for games, for example? So that's me. I'm going to leave it to my next colleague to dive a little bit deeper in some different projects. And I hope this gives you a sense of what kind of work we do at CMIC. Right, Motion, take it away.
Thanks, Ian. Kia ora, my name is Motion, and I'm the interactive designer at CMIC. I graduated out of the School of Architecture and Design and did my thesis on the topic of virtual reality. Love control, Ian?
Yep.
Right. So it was after completing my thesis that I realized that I have a deep passion for virtual reality. And here you can see a couple of my mates testing out an application I made called Heho and the Taniwha, which was a horror application, so there was a lot of jump scares. And I later released this onto the Oculus Store, which got a bit of traction for, multi-driven games, which was quite cool for me. And this leads me to MIR VR, which is a project I did at CMIC. It was my first project. I did this project actually with Luke and Regan from the School of Architecture. And the goal of this project was to quickly capture an environment so we can produce interactive simulations within that environment. And a little bit of background, Luke is from, like I said, the School of Architecture, and he did his summer scholar paper right here at CMIC. So to scan an environment, this consisted of getting the Leica scanner, scanning the floor, then generating that environment via Matterport, and then bringing that 3D generated mesh back into Unreal so we can create some simulations. So here's a comparison shot. So the top half is real life. The bottom is scanned. You can see that the scanned environment isn't like the best, it's not perfect. It's a little rough around the edges, but the goal was to quickly capture this environment. So Rebecca, you could go into the School of Architecture, you can scan your own environment and then get your own simulations within that environment. And one of the simulations we actually done was a fire escape simulation where the goal for the user was to simply get to the fire exit, and as time went on, the fire would get larger, it would obscure your vision through the smoke. And yeah, this one was quite simple compared to our next one, which was the active armed offender simulation, where we actually went by the policies set by the university and the police, which was run, hide, fight. And the first option, if you can, run to an exit. If you can't do that, hide underneath a table, hide in a room, barricade the doors. If you can't do that, then your last option was to fight. And you can do all those three within a simulation. And to conclude with my short presentation, I'd just like to say that VR is becoming a lot more mainstream within architecture projects, and programs like Lumen and Twinmotion actually support VR, but the interactions are quite limited. And you guys in architecture know it's not just about showing the space, but how people interact within that space. So I think that's where CMIC can kind of help with, you know, being the avenue for the School of Architecture to kind of help build those interactions, not only creating custom interactions within the VR world, but visualizing how other people actually interact within that space. And with that being said, I'd like to pass it on to my colleague, Daniel.
So, hello everyone. Oops. Not passing the slide. Oh, no. Okay. So, hi everyone. My name is Daniel. I'm a postdoctoral researcher here at CMIC, and I'm Brazilian, and but I did my PhD in Portugal. And some of my topics that I like that I'm researching is virtual reality, augmented reality, and more towards the human factors. So, my name. So as I said, and like if you think about CMIC as having like the UX component, which is more like the cognitive science and behaviors part, and the CMS where you have more the computer graphics and machine learning hardcore graphics. I'm somewhere in the middle. So one of the topics that we are addressing here at CMIC is remote workspace collaborations. So as we can see now, everybody needs to work to remote and everything. So, but in some cases, people, you need some more context, you know? So for example, like in this case here, you don't know, there are some problems. For example, you don't know who I'm addressing sometimes. If I want to address someone specifically, you don't have like the eye contact. So for example, some people also don't have, they need to show something about their own environment, and this is a little bit lost. So one of the things that we are addressing here at CMIC, and a thing that I'm personally interested in, is that part of remote workspace collaboration. So, so in that things we can use VR, AR, so people can have a better context of the real environment, so they can work remotely but feeling at the same place, so they can work together face to face. Well, of course, this can be used. This can be done by human teleportation, but this is like still in the science and fiction, and it can also be a solution. And it could be inconvenient to travel, but can cause severe health and safety issues. So this is particularly one thing that we've been working on, which is augmented virtual teleportation. So in this thing, people can converge both virtual and augmented reality, so they can work together live in a real augmented environment. They can feel in the same place with like a 360 camera that makes people teleport to the remote space and communicate face to face. So this is done by using the 360 cameras. So one person in VR can be teleported to a remote space. So they can augment the environment with virtual objects, and they can communicate using face to face and a 360 video, which is put on the remote side. And a local person can have, using augmented reality glasses, they can see their partner by where the 360 camera is, and they can collaborate with them via this avatar. So we made some applications to showcase our prototype, and this can benefit from face-to-face interaction and spatial awareness. So for example, this can be used in the case of remote assistance, So someone can guide another person, in this case, like in the kitchen scenario, doing recipe. So also training people to perform tasks or to use equipment by rendering virtual replicas of the environment, the equipment. And also there's obviously the application of interior design, where one can have like a 360 camera mounted on the other place, and there's someone there with AR glasses, and they can communicate and be teleported to the remote space where they can furnish a real remote room. So they can see like, and also the objects are blended so they can match the real world's lighting on the remote site. And also the idea of remotely presenting. So someone can be teleported to like a real classroom or the other way around, and can communicate and showcase elements of the real world using our tool. So, so that said, we have some future research directions on this augmented virtual teleportation thing. So, for example, this is still limited to one-to-one collaboration. So, in the future, we want to pursue like multiple users in both sides, and also like we are only using audio and visual stimuli, so we want to go in the multi-sensory direction, so include other senses like haptic feedback, smells, and everything, and also have more applications about and use cases about for our application. So obviously architecture, as we showed, and others such as engineering and medicine. So now I can pass my word to Nadia, who's gonna talk a little bit more.
Thank you, Daniel. Hello, everyone from me. I'm Nadia Pandiri. I joined CMIC a few months ago, like a couple months ago, as a lecturer. And then, of course, with the lockdown, I didn't get the opportunity to engage in meeting people around the campus as much as I would have liked. I have an interdisciplinary background across psychology, engineering, and computer science. And my research is primarily, sorry, I have the wrong slide here. Don't know why. There, sorry. Oh, there's a bit of a delay, sorry. So, and my research is in the area of human-computer interaction and sustainability. So I have done some research around emergency response, food practices, but also kind of other aspects of more people sustainability, such as mental health and well-being. Within CMIC, I guess I'll be closer to the kind of the user experience group. That will be my kind of natural space. And my specific focus is kind of understanding and evaluating people's interactions with technology in the real world. I'm particularly interested in people's lived experience. And this allows for designing kind of more meaningful intervention services and technologies that are sensitive to people's values and practices. So as part of this research, of course, as you might imagine, the physical and built environment are an essential consideration in my work. It is not possible to design or evaluate technologies looking at the lived experience without considering people's embodied interactions with one another and their environment. So architecture has been really kind of critical, I guess, in what I do. And an early example of that was the slide I was showing earlier, which is part of my PhD kind of thesis quite a few years ago, where basically I was looking at the role of kind of interactive technologies in supporting formal and informal learning in kind of higher education spaces. I conducted a series of ethnographic studies in various kind of innovative higher education buildings. looking at kind of how people's actual use of the technology primarily, but the space, of course, as well, and contrasting that with the anticipated use of those spaces. And of course, as you might imagine, there were a number of differences between what was envisioned people to do in those spaces and what was actually happening. So through that, I was kind of identify different factors that allow us to account for those differences and kind of almost repair them in a post-occupancy type scenario. Things around kind of legibility, which can be both infrastructural, like the affordances, as we know, but also social legibility of spaces. Aspects around legitimacy and sense of ownership, but also customization and appropriation. So as you can tell, this is kind of a very relevant to VR and CMIC as well, because specifically now within CMIC, my interest is kind of understanding and enhancing the user experience in these kind of immersive environments. And this is kind of, as VR and AR, they're not new, but they're now becoming much more accessible and much more ubiquitous in our everyday life. So this is a great time for kind of extending the research that is currently happening in laboratory and control kind of settings in VR to kind of people's everyday lives and kind of real world practices. So I'm particularly interested to kind of go beyond ergonomics and human factors or kind of usability studies of these kind of immersive environments and really look at what does it mean when we transition in our real life from these kind of immersive environments to our built environments or our physical kind of environments. And also, what does it mean for these immersive environments to kind of extend our built and physical environment? Sorry. So specifically, I'm interested in kind of obviously, what is the current user experience of such spaces? How can we support people to inhabit those spaces comfortably? And what does comfortably mean in this scenario? Do we have the right metrics to kind of understand this kind of comfort or the current experience, or do we need new metrics for these environments? And also, what are kind of some of the key symbolic and functional and social elements that allow us to kind of understand and design for those spaces? And just to bring an example, I mean, religious kind of buildings, churches is a very kind of good example in that, because there's symbolisms within that built environment that kind of enhance people's experience there. But recently we saw a lot of people, due to COVID, they had to kind of actually transfer that practice into a virtual environment. How was that experience? What does it mean to kind of, what kind of elements you need to almost replicate that kind of symbolic element that you have in a normal church within a VR environment? Or going to kind of Mohsin's example earlier about the fire training kind of VR application. I mean, most of us have participated in fire drills in our environments, but to have a fully kind of immersive experience like that, you see the fire, or maybe you even experience the smoke or other kind of sensory elements. This is something that so far only kind of trained firefighters, professional, basically emergency responders usually engage in. So what are the implications for everyday people in kind of getting that fully immersive environment? What are the maybe ethical aspects we need to consider, or kind of the emotional and affective kind of impact that we need to kind of consider as a kind of an after of that experience, to make sure that people are still comfortable. So in short, I'm quite interested in how do immersive environments extend, complement, or potentially disrupt our current interactions with each other and our physical and built environment. And there are lots of examples around that. I mean, one of my favorites around considering the disruption potentially, and disruption doesn't have to be a bad thing, by the way, is around food, because I have a particular interest in that, and VR. We see more and more of these kind of VR restaurants happening, where people sit like what you see in the bottom image there, and they kind of see virtually their food, but then they experience something else. And there's some really interesting experiments in that space. So these are some really interesting times, I think, for CMIC and for architecture and VR and AR. And I'm looking forward to chatting some of you if you are interested further. So in short, thank you for listening to us. We would love you to join us. Check our website. We have some scholarships and internships as well. Or if you just want to come and chat about anything, I know we still cannot do a fully big group at level 2, but we can still meet with smaller groups. We are not very far from the School of Architecture, so only 6 minutes away, as you can see here. And we are at the NEC house, so we would love to see some of you there. Thank you, and we are happy to take questions.
Oh, kia ora koutou. Thank you very much for that fantastic presentation, and it's fascinating to see all the possibilities that can be that VR and AR can be used for. So yeah, if everyone could give a virtual clap, you can do that with your reactions. Please do. Yeah, any questions? Perhaps I could start just while people are thinking of their questions. How do you incorporate haptic and smell sensors into this? I just could not work out in my brain how that might be possible.
Well, this is a question that we are asking as well. Like, there is some work in the literature about like remote haptics. So how you can feel like a really sense, like have force feedback. So you have there is something that is really used in medical context, which is like phantom, which is something that it resembles a pen. So like it has been used like in the medical field a long time. So you can feel the texture, for example, if you're like cutting someone or doing like so you can have a sense of surgery and stuff, but and other senses are still like very preliminary and in research phase, right. Which is like you have to really do like some way to recreate smells and try to put it back in there. We like in our previous lab, for example, we bought something that and we tried to use it, but it was not working very well. Right. But yeah. That it's basically something that we it's a question. It's a good question to have because it's a question that there's no good answer yet.
Okay. Oh, very good. And I forgot to say welcome to Victoria, Nadia, and you're very new, so welcome.
Thank you.
Mike.
Yes. Well, kia ora, thank you. It's essentially the same question as yours, I think, Becky, but haptic is more than just what you touch. It is what you feel. And we have a collaboration for quite a large number of years with Marshall Day Associates who help us with our acoustics teaching. And they've just built a quasi-virtual acoustic simulator in their Wellington office, replicating what they have in Auckland, where you can listen to what it would sound like in their test room if there was someone in the apartment next door with good or bad sound absorption in the wall between you who was arguing or playing a stereo and so forth. And with these kinds of headphones, you can get ones that actually do replicate surround sound experience of being in a space given certain sounds being generated and what the properties of the space are. But what we don't yet have is the ability to sit in a room that's cold but sit in the sun next to the window. And I'm certainly intrigued by the whole idea of having all of that. Sorry, someone's phoning me. And it's coming through the same headphones, which is really distracting. I'm really interested in that space of actually virtually trying to experience what it would be like to be in an office where you have glare from the windows, because it's very difficult to replicate artificially the sun shining in your eyes, or even just a bright window. It's similarly difficult to imagine that your ankles are cold because there's a cold draft off the window next to you. But those are very real haptic experiences in an office that VR doesn't yet get to, but I wish it could, because it's a really relevant way of imagining what it would be like to be in a space. So I'm interested in anything you want to do in that area, because that kind of thing is something that intrigues building science students a lot. Just getting beyond predicting the number to actually talking about the experience.
Yeah,
that is indeed very fascinating. I think, like Daniel said, for a lot of these things, it's still kind of, although like I said, they're more ubiquitous, it's still early days, and we're still really getting into grips with the more multisensory and fully experiential aspects, which is why it's really exciting. I have heard of some studies that they look at still at experimental kind of stages, looking at almost what would it mean if your feet are cold, and that's like your real world stimuli, but having a virtual kind of experience where you're by the fire, and whether that kind of mediates or alters your perception. You know, they're using some of these studies as ways to explore around pain management, for example. So there's definitely some area there, some research in that area that is very exciting.
Yeah, and there's also a lot of studies, for example, in perception manipulation, which is basically like you trick your senses to feel in a way that is real, but it's not. For example, there's some recent papers at CHI, like the biggest conference in human-computer interaction in the world, for example, they use like smells to convey temperature, for example, or like the more classic ones that like rotates the world around you, so you can feel that you're walking like a shorter distance than you actually are in virtual reality, for example. So it's like a very interesting kind of feel. And also it's interesting, for example, the thing that you said, like about the real world environment, because it's still preliminary, like to recreate, like to like a real condition, for example, into a virtual environment. But I think it's even more tricky and challenging and exciting, for example, to have, in our case, like recreate, like sense, like model a environment that already exists, and try to capture this and transfer it to like a remote person. This is even more interesting, because you're not just simulating the virtual hypothetical world. You're like recreating like a real remote world. That is even more exciting.
Yes.
Oh, thank you.
Just one other question too, Becky, for Ian and the team. Thank you very much for that presentation. And one of the sort of cunning things that we did was to, the reason we brought you to the Atrium presentation, the CMIC team to the Atrium presentations, is to introduce the capabilities of CMIC within Victoria University. Now, we've all seen some of the things, and Mike, for instance, is interested. Ian and team, how do we actually then move forward? What can we do if we in architecture and design and project management can see areas where, and we're exploring them now. I've just come out of student crits, and 2 of our 3 that I've just done are in the VR area. One's anyway, but so what's the next step, Ian and team? How can we get this conversation going from this Atrium presentation? What's next to do?
I think first, thanks Regan for that very concise question. I think if you ask different people, they'll probably give you slightly different answers to this. But in the past, we've worked a lot with the School of Architecture already. I think mostly with Regan, but also with Dara. And we're always happy to work on things like summer scholarships. I think that's a really great way for us to test out new ideas. And it's also great because the proximity of the two locations makes it really easy for us to have that collaboration. We're also really interested in working on like grants, for example, because I think the challenge for us is that we need to be able to some extent validate or demonstrate the value of the work, the technology or the research we're doing. I think part of that's so great about the School of Architecture is that you often have those answers there, and we can lean on you guys to help us frame and contextualize some of the research you're doing in ways that I think will better, help us to, work on projects together. So I don't know, that's so grants, summer scholarships. We also do have, I guess, a VR lab and other types of equipment that we're happy to share, or kind of if your students want to come and know more about the center, or, we want I'm sure any of our postdocs or researchers, if they want to give a guest lecture, I'm sure that's also on the table. I don't know, Nadia, do you have anything else you want to add to that?
I think what you said, Ian, sounds great. Like Ian said, like there's, anything from a small student project that we can collaborate to a funding application to, we would love to, if you're interested, if you would like to come and present. We used to do pre-COVID some also seminar talks in CMIC, I think every 2 weeks or once a month, and I don't know, I attended a few before I actually started in CMIC. So it would be absolutely great. I'm planning to attend some of your seminar series as well, so I can get a sense of people's research. So, yeah.
Great.
Because I know from both Becky and I, we are very, very keen. I'm speaking for you now, Becky. I haven't actually talked about this, but the Matagamari side is an area that is close to both our hearts, and it's something that we know and we live it and we understand it, but we don't understand it, if that makes sense. And trying to sort of unpick what we should be, like I should be a Maori, therefore I should do this, as opposed to I am a Maori, therefore I do this, is kind of complicated to actually get your head. So that'll be something for you, Nadia, to, if there's a huge field in there. And Motion and Daniel, we did the scanning of the building, and it's coming out much better with the Leica software. So we're in on Thursday morning to finish off just the final little scan. So,
cool.
Yeah, actually, I was going to add to that. Actually, yeah, that's also something that's really interesting for us, because, with a lot of grants, there's this section about Vision Mataranga, right? And I think what's really important for our center is that we need to be able to really truly embed that worldview and that perspective and that mindset into the research you're doing. And so I don't know if you know, Regan, we're trying to work more closely with people like Kevin Shedlock up at the School of Engineering and Computer Science. But yeah, this is something that we've had a discussion about, and we're definitely keen on figuring out how we could do that a bit more, especially since a lot of the people at CMIC are also international staff as well, and so they might not have been exposed to this particular worldview or perspective. So I think it'll be a really great experience for us as well.
Cool. Any final questions? No. Well, it feels like there's all sorts of research possibilities and collaborations that are possible here. So let's do keep up that conversation. Because I think there's, I'm starting to imagine what might be possible. So you might get an email from me. But thank you very much for your talk. It was great and fantastic to see what is possible in that world, which is very foreign to me. But yeah, fantastic. So thank you very much. And next week we've got Mark Carell speaking at 1. So come along then, same time, same place. Hilda.
Thank you, Becky.
Thank you so much.
Thank you all for being here.
Thank you.